tangent vectors, normal vectors, and curvature in space. 3 dimensions. Suppose you're given the position vector in space. It's ti plus t squared j plus t squared over 2k. They ask you to find v, a, and the length of v. Well, to find v of t, we take the derivative of r. 1, 2t, and half of 2t, which is t. When you bring down the 2, it kills off the 1 in the bottom. That's v of t. Now if you want the magnitude of v of t, you square the I component, you square the j component, you square the z component, you denote you're adding them up and taking the square root. 4 squared t plus t squared is 5 squared t, or 5t squared. 4 squared t plus an understood 1, 4t squared, yes, plus 1t squared is 5t squared. Okay, so we answered those two. Now we want to find a of t, acceleration. You have the velocity, and you take, and here it is, and you take the derivative component by component, you'll have the acceleration. The derivative of 1 is 0, derivative of 2t is 2, is 0 and 2, and the derivative of an understood 1t is 1. Okay, so that problem is over. Just doing it with 3 components. And we want to find r of 2. What does r of 2 equal? And they tell us that a of t is 1, 1, 1. And v of 0 is 0, the 0 vector, and r of 0 is also the 0 vector. And that's what they give us. Now, if I integrate, I will find, I'll have to tell you what I'm integrating. If I integrate a, I will find b. So I integrate a. The integral of 1 is t. Integral of 1 is still t, plus your constant. But they give us a way of finding the constant. They tell us something about v of our values. On one hand, v of 0, well, it's 0, 0, 0, plus c, which is just c. Okay, and they also tell us it's 0. V of 0 is 0. That means c is 0. So, knowing the value of c, I can tell you exactly what v of t is. It's this. Because when you add on the 0 vector, you get back t, t, t. Okay, that's v of t. Now if I integrate, I'll find r of t. Integral of t is t squared over 2, and of course, the integral of t will not change, plus the constant. C1, comma C2, comma C3. But they gave us initial value. They told us r of 0 was 0. Well, on one hand, r of 0 is 0 squared over 2, which is 0. 0, 0, plus c. It's c. On the other hand, they told me that r of 0 was 0. So now I know what, I meant to say r of 2. Now I know that c is 0. So I can update the second line from the bottom. I can now update this. I can say c is 0. So r of t is t squared over 2, t squared over 2, t squared over 2. And I wanted to know from the beginning what r of 2 was. So instead of t, I say 2. 2 squared over 2 is 2. 3 times I'm going to get that. And that's the answer. That's what r of 2 equals. And that's what they asked us to find. Find r of 2. Okay, here's a good problem. You want to find the equation of the tangent line at a given point on a given function. The r of t is t squared 2, and the point is 0, 0, 0. Now, for t to be 0, and t squared to be 0, and t to be 0, that implies t is 0. The 0, 0, 0, that was a point in the XYZ system. So, let's go and find t. R prime is 1, 2t1. Took the derivatives of each of these separately. And the norm of this is 1 squared, which is 1, plus this squared is 4t squared, plus again 1 squared is 1. 1 plus 1 is 2, so you get 2 plus 4t squared. 1 plus 1 is 2. And then the tangent would be 1, 2t1 divided by the square root of 2 plus 4t squared. Well, the slope at 0, 0, 0, which means in this case t is 0. That is t of 0. Not the 0 vector, but actually the number 0 this time. T equals 0. 1, 0, 1. 1, 0, 1. 2 times 0 is 0. Divided by 4t squared is 0. 2 plus 0 is 2. So it's the square root of 2. So it's the square root of 2 over 2 times 1, 0, 1. Now, you have some vector. Let's just suppose it's that vector. It's a component vector. Starts at 0. And then you scale it. Gets bigger or shorter. But if that's still the tangent line, that this is the this is the direction of the tangent line, and this gives it a length. I don't care about the length. I can just really deal with 1, 0, 1. In fact, if you really think about it, you didn't have to bother finding r prime of t, because you're just dividing, it's a scalar. You're just dividing each value or multiplying each value by 1 over the square root of 2 plus 4t squared. It's just scaling it. The direction is this right here. That's really all I'm looking for. And when t is 0, it's 1, 0, 1. So the answer goes like this. X is going to be 1t plus 0. Plus 0. That is 1t. And y is going to be 0 t's plus the second value, which is 0. That is, x is 1t, or t, y is 0, and z is 1t plus the 0 value of the point. That's just t. The x is equal to t, y is equal to 0, and z is equal to t. That's the equation in parametric form of the tangent line to r of t at the point 0, 0. They told you that r of t was t squared, 2/3 t cubed, and we're doing this at the point 2, 0, 0. I meant to say 3, 9, 18. Those points just weren't going to work. 3, 9, 18. At 3, 9, 18. Of course, those are not t values. You have to start seeing that. Those are not t values. It's a triple. It's 3 numbers. That's an x, y, and a z. Well, if t was going to equal to 3, well, that means t is 3. If t is 3, t squared should be 9. Oh, we're on a roll. And if t is 3, that would be 27 and 2/3 of 27. Oh my. 2 times 9 is 18. T is 3. That tells me t is 3. And if you're kind of short on time on an exam, well then t is 3. You don't have to check the others. But if you did and it didn't check out, you stop right there and you say the problem's not valid. That point's not on the curve. That point's not on the graph. But it is, so we need to continue. So r prime of t is 1, 2t, 2t squared. So basically, this is proportional to t of t. It's proportional to it. Maybe there's some number k there, but I don't care about the k. Now, k of course is 1 over the length of r prime. I don't need that, okay? So now, t of 3 is proportional to, just plug in 3 for t. You get 1, 6, 18. So here it is. So x is equal to 1t, y is equal to 6t. These are like the slopes. and z is 18t. Plus 3 plus 9 plus 18. Plus 3 plus 9 plus 18. That's the parametric equation of that tangent line. Pretty cool. Okay, a few more problems. They tell us that R of t is t 2t negative 3t. We want to do things with t equaling the number 1. And what we want to find out is the following. We want to find out t of t, n of t, a sub t, and a sub n. So first let's find t of t. Actually, we want to find it when t is 1. T of 1, n of 1, when t is 1. So we need to find r prime of t and the length. It's 1, 2, negative 3. So r prime of t, the length of that is 1 squared plus 2 squared plus 3 squared, square root of 14. So t of t is the vector r prime divided by the length. Turns out that t of 1, this doesn't depend on t. It's a constant function of t. So there is your answer. If you prefer, you can write the understood 1 over square root of 14 as square root of 14 over 14 times the vector 1, 2, negative 3. So I found t of 1. Now we want to find n. Let's find n of t. That n of t is t prime of t divided by its length. Well, t prime of t, the square root of 14 stays in the bottom, but when you take the derivatives of each of those constants, you get 0. Divide each of those values by square root of 14, they're still zeros. Well, you can find t prime, the length of t prime of t. This is undefined. But n of t is defined to be t prime of t divided by the length of t prime of t. Actually, I take back what I said. I don't know what I'm thinking. T prime of t is the 0 vector. Its length is 0. Its length is 0. So you get t prime of t, which is the 0 vector, which is okay. But then you divide it by 0. That's undefined. Okay, n of t is undefined. Let me get rid of some of this in the middle. To find a sub t, just remember that a sub t is a of t dotted with t of t. which I just erased. Lovely. So now, a of t, this is the derivative of r prime. It's r double prime. A of t is r double prime, which is the derivative of r prime, which is 0. Which I'm happy because regardless of what t of t was, the dot product will be 0. Because 0 times whatever that was is 0, plus 0 times what that is 0, plus 0 times what that is 0. You add up zeros, you get 0. So a sub t is 0. Now, a sub n, so now if a sub t is 0, then a sub t at 1 is still 0. It could have been a function of t, but it wasn't. So even when, so this number happens to equal 0 when t is 1. Okay, now, so we have that. Now, a sub n of t is our a of t times n of t. Now, a of t is 0, 0, 0. N of t is undefined. So this answer is undefined. You can't find a sub n of t. It's undefined. Number 20, in this next problem, they tell us that r of t is equal to 2 cosine t, 2 sine t, and 1/2, t over 2. And they tell us that we're concerned when t is equal to pi over 2. And they want us to find t and n and this b formula, which they tell us is b cross n. So we want to find t n and t cross n at pi over 2. So r prime of 2 is negative 2 sine t, 2 cosine t, 1/2. So r prime of pi over 2. Well, the sine of pi over 2 is 1 and the cosine is 0. So negative 2 times 1, 2 times 0, 1/2. That's r prime. So what is the length of r prime at t over 2? Well, you square the 2, don't bother squaring the 0, plus you square 1/2, which is 1/4. But 4 plus 1/4 is 4 1/4. It's 17 quarters. 4 1/4, 4 plus 1/4 is 4 1/4. 4 times 4 plus 1, 17 quarters. Square root of that. I do not know the square root of 17, but I certainly know the square root of 4. So to find t, we just divide the last two. T of t, actually, you already plugged in pi over 2. t of pi over 2 is this vector, negative 2, 0, 1/2, divided by square root of 17 over 2. Let me distribute the 2. We get negative 4, 0, 1. I got rid of the fraction. And dividing by square root of 17 is the same as multiplying by square root of 17 over 17. Because this is 17 over the square root of 17. I multiply numerator and denominator over here by square root of 17 over 17. And instead of dividing by that, I multiply by the reciprocal. And that is t. Okay. Now we want to find n. Now we want to find n. Now, the problem here is we need to find t prime of pi over 2. But first we need t prime of t, which actually we don't have. So I need t of t. It is negative 2 sine t 2 cosine t 1/2 divided by the length. And the length of r prime of t, well, when you square this, you'll get 4 sine squared t, and you square that, you'll get 4 cosine squared t. That's going to add up to 4 plus 1/2. So either way is not a function of t. The square root of 4 plus 1/4. The square root of 4 plus 1/4 is square root of 17 over 2. Okay. So we get t prime, and we divide this by, now keep in mind, if I multiply the top by square root of 17, I'll get that. If I multiply the bottom by square root of 17, I get that. So I want to divide by this. I want to divide by 17 over 2 square root of 17. 2 square root of 17. Square root of 17. This is t of t. And if I distribute the 2, I get square root of 17 over 17. So when I distribute the 2, that last component becomes 1, a nice integer. It used to be a fraction, now it's an integer. That's t of t. Now, the length, hold on, is that really correct? That's just t of t. Okay, so what we want is t prime. So this stays the same way. Square root of 17 over 17. The derivative is negative 4 cosine t, negative 4 sine t, 1. Okay. The length of t prime of t, well, the square root of 17 over 17 stays. The length of this, when you square this, you're going to get 16 cosine squared. Plus, when you square this, you'll get 16 sine squared. But that's 16. plus 1 squared. You're going to get the square root of 17 times the square root of 17, which actually happens to be 1. Interesting. Happens to be 1. Okay, so that tells me that t prime is n. Because t prime, n of t happens to be t prime, which is this mess, divided by the length of t prime, which is 1. Don't have to divide by 1. So that's n of t. Okay, in this little corner here, I'm going to find n of pi over 2. Well, I know it's going to be the square root of 17 over 17 times. The cosine of pi over 2 is 0. 4 times 0 is 0. Minus the sine of pi over 2 is 1. Negative 4 times 1 is negative 4. And 1 is always 1. So that is n of pi over 2. Now, they want us to find the B formula. They want us to find B. In B, if you study some physics, you'll learn to understand why B is T cross N. Is T cross N. Now, T is right here in the bottom left. That's T. It is the square root of 17 over 17 times negative 4 sine T 4 cosine T, except that's not what we want. We want it at pi over 2. T of pi over 2, T of pi over 2 is this right here. It is the square root of 17 over 17, negative 4, 0, 1. And this gets crossed with n of t, which is the square, which is right here, n of pi over 2. Square root of 17 over 17 times 0, negative 4, 1. And when you cross two vectors, they have scalars, you can just multiply them. Remember, this is 1 over square root of 17, and that's 1 over square root of 17. You multiply them, you get 1 over 17, times the determinant. Negative 4, 0, 1, 0, negative 4, 1, I, J, K. So once we figure out that determinant, having used that word before, at least I don't think I have, it's called a determinant. Once we find that out by using the spaghetti method, we'll have our answer. Always minus some silly error I may have made. So it's 1 over 17, I, J, K, negative 4, 0, 1, 0, negative 4, 1. Repeat. Okay. Is this product, which is 0, plus that product, which is 0, plus this product, which is 16K, minus this product is 0, plus this product, which is negative 4i, minus 4j. You take away a negative 4i, you get 4i. You take away negative 4j, you get plus 4j. You add 16k. I guess I'll factor out a 4. 4 over 17 times 1i plus 1j plus 4k's. And there is b, which is t cross n. Okay. We know that the curvature is t prime it's the length of t prime and we can also think of it as r prime of t cross r double prime of t, the length of that cross product, divided by r prime of t, or the length of that to the third power. So if they tell you that RT is t squared 2t t squared, they ask you to find the curvature. What you can do is find r prime, r double prime, cross them. R prime of t is 2t 2t, and we need the length for the bottom. We also need r double prime. R double prime of t is, the derivative is 2, the derivative is 0, the derivative is 2. And like I said, we need the length of r prime. It's 2t squared, which is 4t squared, plus 4, which is t squared, plus another 2t squared, which is 4t squared. You can clearly factor out a 4. So I have t squared plus t squared, because I factor out the 4, which is 2t squared plus 1. And the square root of 4 I happen to know is 2. Square root of 4 is 2. So that's the length of r prime. Okay. So let's do r prime cross r double prime. R prime cross r double prime. 2, 0, 2. I, j, k. Repeat the first two columns and then compute. You get 4i plus 4tj plus 0k's minus 4k plus 0 plus 4t in the j direction. 4t in the j direction. 4tj minus 4tj is 1. So I get 4i minus 4k. 4 times I minus k. Okay, so I get 4 times I minus k. Now I need the length of r prime cubed. here's the length of r prime. You cube 2, you get 8. If you have the square root of anything and you cube it, that means the square root times the square root of something times the square root of something times the square root of something. Well, the square root of something times the square root of that something is that something times the square root of something. So the something happens to be 2t squared plus 1. So we get 2t squared plus 1 times the square root of 2t squared plus 1. And that is your curvature. Okay, so, well, 4 goes into 8 2 times. So you get I minus k divided by 2 times 2t squared plus 1 times the square root of 2t squared plus 1. If I multiply top and bottom by the square root of 2t squared plus 1, the top would be this. And the bottom will be 2 times 2t squared plus 1. Now this times the square root of 2t squared plus 1 that I multiply top and bottom by will give me 2t squared plus 1. Times the same thing gives it to me 2 times. I'm multiplying the top by this. I'm multiplying the bottom by 2t squared plus 1. This product is 2t squared plus 1 times another one makes the bottom 2 times 2t squared plus 1 squared. And that is what I put in the bottom. Times I minus k. That completes this section entitled Tangent Vectors, Normal Vectors, and Curvature in Space. We just up in things from 2 dimensions to 3 dimensions. And some people call 3 dimensions as space. Most calculus books call it space.